Hello everyone, welcome to Design Hub. In Design Hub, we provide quality technical content related to the design industry using practical concepts. So, to upgrade yourself, please subscribe to the channel and press the notification bell to get notified every time we drop a new video. In this second video of GD&T, we will do the modeling and drafting of coupling using the required GD&T symbols. Now, let's jump into the Solidworks window. Let's create a new part. Select the front plane to sketch on it. And for reference, draw the centerline to activate the revolve command. We will start sketching on the right side of the center line. Sketch the required shape of a coupling roughly. Giving the part its total length equal to 171 mm. Let's give the height of AB equal to 30 mm. Give the diameter of circle C1 equal to 20 mm. Now, give the radius of the circle C2 equal to 6 mm. Just tweak the current sketch into the required shape. And give the height of CD equal to 40 mm. Establish 5 mm as the height of EC. Establish a 15 mm diameter for circle C3 at the coupling's middle portion as well. Define the diameter of circle C4 equal to 20 mm. And the diameter of circle C5 should be equal to 9.50 mm. Establish the height of FG equal to 2.50 mm. Now, from the sketch toolbox, we will take the centerline and draw it horizontally from point H. And keep the angle between the centerline and the line segment HI equal to 45 degrees. After establishing all the required dimensions to make the part fully constrained, it is time to use revolve command to make the coupling three-dimensional. Select the center line as the axis of revolution. Just quickly have a look at all the given dimensions. Now, let's specify the material of the coupling. The material is AISI 4130 steel, which is normalized at 870 degrees Celsius. Here are some facts about this material. It is a popular general-purpose medium carbon, chromium molybdenum steel. The versatility provided by heat treatment options allows it to achieve a wide range of toughness and strength values. Hardenability, strength, wear resistance, toughness, and ductility are all excellent. Now, from the feature dialog box, use fillet, and apply a chamfer of 1 mm with 45 degrees angle at the bottom of the coupling. Also, use the fillet feature, and give the radius of 1 mm to the upper side. And 0.5 mm of fillet radius to the lower side. Use a wizard hole, and select a type of hole needed. Here, the hole is a dowel. Now, position a hole on the top of the coupling using the 3D sketch feature. Select 10 mm as the size of the hole. We will keep the end condition as it is and check the hole using the section view. Uncheck the near side countersink option. Let's change the value of the end condition of the hole to 20 mm. Checking it once again, and it is looking okay now. Now, apply the chamfer of 1.50 mm, with an angle of 45 degrees on top of the hole. We will save the part in the required location and name it accordingly. Now, we will make a drawing from the part. And select the A4 sheet size. First, we will put the front view of the coupling. And then see if the scaling of the drawing is necessary. Then we'll go to the drawing section. And we will use the break view command because it allows the drawing view to be displayed at a larger scale on a smaller drawing sheet. You can select the cut direction. Here we need a horizontal break line. Also, select the break line style. I will select the small zigzag break line. Place both the break lines in a required position. You can also define the gap between these break lines. Now, we will give dimensions to the drawing using Smart Dimensions. Let's introduce the height of the CD, which is 40 mm. You can change the layer color as needed for annotations. Now, introduce the height of EC, which is 5 mm. The diameter of circle C4 is 20 mm. The diameter of circle C5 is 12 mm. The diameter of circle C1 is 20 mm. The diameter of circle C3 is 15 mm. Now, we will project the top view of the coupling using the projection view command. After that, we will create a section on the top view, and place the sectional view. But to place it out of alignment, right-click on the sectional view. Go to Alignment, then break the alignment. Here we need to show the machinist the specifications of the dowel hole. So, we will use the Crop View command and sketch a circle on the sectional view to show the required portion. Now, using the Detail View command, we will show the fillet radius and small dimensions that are not clearly visible on the main drawing. Let's introduce the length of the coupling, which is 171 mm. Also, introduce the dimensions of the dowel hole. The depth of the dowel hole to the shoulder is 20 mm, and the depth to the tip is 23 mm. Using the hole callout command to introduce the depth and diameter of the hole, which are 20 mm and 10 mm respectively. Introduce the angle for the tapered part, which is 135 degrees on both sides. Now, let's introduce the surface finish. Here, the surface finish symbol indicates that the surface roughness must be obtained by a method other than machining, and the required value of surface roughness is 3.2, Micrometer. We will introduce the chamfer dimension, which is 1 mm, with an angle of 45 degrees. Also, introduce the chamfer dimensions in section view, which is 1.50 mm, with an angle of 45 degrees. Now, introduce surface finish for the upper part of the coupling. Here, the surface symbol indicates that it is necessary to obtain surface roughness without removing any material. Now, we will introduce dimensions to the detailed drawing. The fillet radius on the upper side is 1 mm. And at the bottom, the radius is 0.5 mm. Also, introduce the groove width, which is 2.50 mm. Finally, check if GD&T symbols and the given values need to be corrected. That is all for this video. We will learn more about GD&T in the upcoming videos. Thanks for watching. Until then, learn and grow.